Okay, this is page 266 of the Incredibles book. We are doing natural log of integration. All right, so here we go. Okay, so you should be already familiar with this. The integral of 1 over x is natural log of absolute value of x plus c. Or if I have dx over x, that's natural log of x plus c, absolute value of x plus c. All right, sorry. This is my second attempt because my cat. Never mind. All right, so this becomes 2 times the integral of 1 over x dx. What I mean by that is, so this is just a regular number, 2, so I can take it out of the integral, right? 2 times 1 is 2, but I took it out. So this becomes 2 times the natural log of the absolute value of x plus c, because now I just have the integral of 1 over x dx. And the integral of that is natural log of absolute value of x plus c. Okay, B. Now, why is this one over here? This one emphasizes the fact that in order to integrate this, I need the derivative of the denominator out here somewhere, or in the numerator. So what I want is the derivative of 4x minus 1 in the numerator. So I just need a 4 up there, because the derivative of 4x minus 1 is 4. But I can't just throw it up there. To compensate for the fact that I put a 4 up there, I'm going to put a 1/4 on the outside, right? So 1/4 times 4 is 1. Okay, so I have not changed the problem, but I can now integrate this because the derivative of the denominator is in the numerator. So when I integrate this, this becomes natural log of the absolute value of 4x minus 1 plus c. And that's it. That's it. Okay, so that 4 gets absorbed because I needed it to do this integration, right? I need the derivative of the denominator to be in the numerator. All right, moving on to C. Yeah, so see, this was my first attempt, and the cat stopped my video. All right. C. Yes, I'm complaining about my cat. All right. This is the same thing as -7 times 1 over x dx. So I can integrate that. So it's -7 natural log of absolute value of x plus c. And yeah, that's sufficient. D. So what's the derivative of the denominator? The derivative of this denominator is -5. So I need a -5 in the numerator. So I'll multiply the numerator by -5. To compensate for that, I multiply by -1/5. So I'm just going to rewrite it so you can see better what it looks like. Right, I needed the derivative of the denominator in the numerator. The numerator had a 1 in it. To compensate for the fact that I put a -5 up there, I'm going to multiply by -1/5. So essentially, I've multiplied the problem by 1, because -5 times -1/5 is +1. So I am multiplying the integral by +1. But when I integrate this, the -1/5 sticks around while the -5 goes away. Absolute value -1/5 natural log of the absolute value of 2 minus 5x plus c, and that's the answer. E. So here, what's the derivative of x squared minus 7x? It's 2x minus 7. So there's nothing I need to do. I just take the natural log of absolute value of x squared minus 7x, because that's in the form of du over u. The derivative of the denominator is in the numerator. Okay, going on to F. Why is there a pair of scissors on my desk? Yeah, okay. All right. Here, what's the derivative of sine 2x? The derivative of sine 2x is 2 cosine 2x. So this is the end. Oops, I don't need that because I'm going to integrate it. It's natural log of the absolute value of sine 2x plus c. That's it. And then next one. All right. What's the derivative of the denominator? The derivative of the denominator is 6x squared minus 9. Well, that's not quite there, but it's missing a factor of 3. So I can multiply by 3. If I multiply the numerator by 3, I get 6x squared minus 9. Copying the denominator. I multiply the numerator by 3, so I compensate that by multiplying by 1/3 on the outside. So now I have the derivative of the denominator in the numerator. So just 1/3 natural log, absolute value 2x cubed minus 9x plus c. Then h. Okay, h. So here, what's the derivative of 3 minus x? -1. So I compensate for that, putting the negative on the outside. So I'm just writing it so you can see what's going on. Right? So the derivative of 3 minus x is -1. I multiply the numerator by -1, so I got to multiply the outside by negative. So it's negative natural log absolute value of 3 minus x plus c. That is it for page 266. Let's jump to page 267. So here we go. It says find the area of the region bounded by the graph of y equals x over x squared plus 1. Okay. And the x-axis and the line x equals 3. So what does the graph of this look like? The graph of this looks like this. It looks kind of like this. Okay. Where at x equals 0, it's 0. And the x-axis is there. And looking for x equals 3. So it's over here somewhere. So you're going to go from 0 to 3. And it's just that curve. So that means you're going to do this. Integral from 0 to 3 of x over x squared plus 1 dx. That's when it says find the area of the region bounded by the graph and the x-axis. Remember, that's just an integral. The only thing missing from this was I didn't know what the lower limit was. Best thing to do is just check to see when is this equal to 0. X over x squared plus 1 equals 0 when x equals 0. All right, and then I integrate this. So this, what's the derivative of x squared plus 1? The derivative of x squared plus 1 is 2x. So I'm missing a 2. Put a 2 up there, compensate for that 2 by multiplying by a half. So it's 1/2 natural log absolute value of x squared plus 1 taken from 0 to 3. So I'm going to work that out. So it's 1/2. I'm going to put the 1/2 on the outside and just take the natural log and substitute those numbers. 3 squared is 9 plus 1 is 10. So natural log of 10 minus natural log of 1. Right? When I plug in 0, I get 0 plus 1, which is 1. I dropped the absolute value signs, or did I? Right? The absolute value of 10 is 10. The absolute value of 1 is 1. So I've done the actual thing. All right. Natural log of 1 is 0, so it's minus 0. So that's the answer. And here we go. Now we're doing example 3a. This is going to need a little side work. So whenever the degree of the numerator is equal to or greater than the degree of the denominator, you're going to do long division. So I'm going to do long division on the side here. I'm doing long division on the side. It's the denominator into the numerator. What was the numerator? All right, x squared plus x plus 1. So just a reminder how to do long division. You compare the first terms. X squared times what is x squared? Well, only 1. Now take this and multiply everything by that 1. So 1 times x squared is x squared, and 1 times 1 is 1. I'm going to put it under the other constant. And then, remember, long division is subtraction. X squared is canceled, the 1's cancel, and I just have an x. So when the degree of the term over here is less than the degree of the divisor, you stop. So that's the remainder. So x is the remainder. So it's x over x squared plus 1. So this fraction is equivalent to, so I'm going to rewrite it the integral now, 1 plus x over x squared plus 1. And now we do the integration. All right. So I am also going to split this up. So it's 1 dx plus x over x squared plus 1 dx. Okay, so this one needs a 2. Compensate for that 2 with a half. Now integrate. Integral of 1 is x. Integral of that is 1/2 natural log absolute value of x squared plus 1 plus c. That's it. That's the answer. Okay. All right, let's go on to b. Oh, by the way, you could rewrite that as x plus natural log of the square root of x squared plus 1 plus c. Remember, if you have a coefficient of a log, you can rewrite it as an exponent. If I have an exponent of 1/2, that's the same as square root. I don't need to worry about absolute value because x squared plus 1 is always positive. B. So, again, I have to do long division because the degree of the numerator is higher than the degree of the denominator. So I'm going to do that division here. 2x plus 1 into 2x squared. And I didn't write it. I didn't give enough space. So let's write it over here. 2x plus 1 into 2x squared plus x minus 2. here. All right. Come on, go down, go down, go down, go down, go down. All right. 2x times what is 2x squared? It only takes an x. Take that and multiply both terms by that x. So it's 2x squared plus x. Subtract. That means all of this cancels. The remainder is just minus 2. So it's minus 2 over 2x plus 1. So I'm going to rewrite that. So this is rewritten as x minus 2 over 2x plus 1 dx. Okay, again, I am going to separate them. So that's going to be x dx minus 2 over 2x plus 1 dx. Okay. All right, so looking at this, the derivative of the denominator is 2, so it's already up there. So I can just integrate this. X is 1/2 x squared minus natural log of the absolute value 2x plus 1 plus c. And that's it. That's B. C. Let's go on to C. Log rule in disguise. Okay, so look at this one. Well, derivative of x plus 1 is 1, not x. There's no x in it. So you can't get rid of that x so easily. So what I'm going to do is I'm going to actually multiply that out. So the denominator, when you multiply it out, is x squared plus 2x plus 1. And now I look at this, and what's the derivative of x squared plus 2x plus 1 is 2x plus 2. So I'm missing a plus 2. So I'm going to do a very strange algebraic trick. I'm just going to add 2 up there. But to compensate for the fact that I added 2, I have to subtract 2. But it's 2 over that denominator. Except this time, I'm going to keep it as x plus 1 squared. Remember, these two are equivalent. X squared plus 2x plus 1 and x plus 1 squared is equivalent. Now, I'm going to split this up. Here, I have the derivative of the denominator and the numerator. Here, I just have 2 times 1 over x plus 1 squared. In fact, let me, oh no. All right. Let me rewrite this for a minute. I am rewriting it as separately. So it's minus, it needs a dx, integral 2 over x plus 1 squared dx. I'm going to rewrite it one more time. I really should just take the integral of that. That one needs no other preparation. It's this one, the second one, that needs preparation. I'm going to rewrite that as 2 times x plus 1 to the negative 2 dx. Okay? Because the derivative of x plus 1 is 1. So in fact, I don't need that 2 anymore. So I'm going to pop it out. Now, so that's going to be the natural log of the denominator because I have the derivative of the denominator and numerator. This is not the negative 2. That's not a natural log. It's only a natural log when the exponent is 1. So in this form, the exponent is 1. In this form, the exponent is 2. So I'm just going to do power rule on that because the derivative of the inside, 1, is here. All right, so this becomes x plus 1 raised to the negative 1. Remember, you add 1 and then divide by a new exponent plus c. So final answer, I just copy this part. The negative becomes positive, so it's plus 2 over x plus 1 plus c. All right, that is A. And then moving on to B, the last example on this page. Okay. Same thing here. So that's going to be, I'm squaring the denominator. So it's 4 minus 12x plus 9x squared. Wow, that's not pretty. Okay, I don't like this at all now. All right, so this one is not as easy as the last one. In fact, this one I did a real word trick of just adding to. This one, it's not so easy to do that. This one is easier to just do a u substitution. Let u, oh, what is this? I'm going to have to put the video on pause while I figure this one out. We're not going to do that last problem. I don't think they're going to give anything that difficult on this, and I'm not sure I can solve it myself. So, fessing up, I'm quitting. All right, good night.